All right, so the last topic for us this semester is about law of cosines, right? And so law of sines and law of cosines, both, just as a reminder as to why we're talking about these, is our way of finding angle measures and side lengths in non-right triangles. Okay? Up until law of sines, we didn't have a way to do that. We didn't have a way to find missing side lengths or missing angle measures when we were dealing with non-right triangles. With right triangles, we just used trigonometry, sine, cosine, and tangent. With non-right triangles, we had no way. So remember with law of sines, again, we're in non-right triangles, and we were writing ratios and using those to find missing sides and missing angles. Why do we have law of cosines? Well, if we're given a situation where we have in a triangle, in a non-right triangle, we have an angle. Say angle A is 42 degrees. And we've been given a couple of side lengths, and maybe it's little c, which could be 12, whatever, inches, whatever, and then little b, which is 20, whatever. Well, we talked about this with the ambiguous case of law of sines. This is not angle side side. We've been given a side and an angle in between, so two sides and an angle in between. So this is side, angle, side. So not a problem. If I want to go find this missing side, let's say we want to go find side A, then we would have paired up these two guys. We would have gone sine 42 over A would equal, and then whatever, right? We could use the B's and go sine of B over 20. Right? But then the problem here in law of sines is that there are two things that we don't know. And we can't solve an equation when there's two things we don't know. So there had to be a way for us to, and this comes from the fact that we've been given two sides and the angle in between. So we've been given side, angle, side. So we had to develop a way to still find the side lengths and angle measures if this happened, and we can't use law of sines. And that's where law of cosines comes from, right? And so to clean this up a little bit, we're going to need to use law of cosines when we have been given, like that right there, side, angle, side, or if we've been given all three side lengths. Okay, don't want to do that because that would make it a right triangle. No, so with that. Sorry, that. Or if we're given three side lengths. Because again, if we tried to use law of sines, we wouldn't know angle A there. We wouldn't know angle B there. If we tried to use C, we wouldn't know angle C. We wouldn't know angle B. So writing the proportions wouldn't work. So law of cosines is where we have to go. And again, that's what we're going to use when we have side, 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 or side, angle, side. Okay? All right, enough talking about why we're going to use it. Let's just talk about using it. And so this is your law of cosines. This is your formula, okay? You don't have to memorize these. We will give you these formulas on the quiz or the test. All you have to do is be able to use it. Be familiar with it. It's a couple of things that you want to be interested in, paying attention to, is that it does kind of look like Pythagorean theorem, but it doesn't mean that the longest side has to go out here every time. What goes out here squared by itself is usually whatever you're looking for, right? So if I'm looking for side A, then I'm going to use this formula because A is by itself. If I'm looking for angle B, right, then obviously I'm going to use this one because that's the one that's got angle B in it. So picking out the right formula is important, but then being able to use it is important too. So let's talk about that. So on number one, we've got a triangle drawn for us already. If we didn't, we'd want to draw one and then label it. So angle A is 42 degrees. Let's do that better. Little b is 12, and little c is 15. So there's side, angle, side. So even if you didn't recognize side, angle, side means law of cosines, then you would try to set up law of sines and realize that you're not going to be able to use that to solve for anything, right? And what we want to figure out is what little a is. Well, then I'm going to use that a squared formula because that's got a by itself. And that's going to make our lives a little bit easier, right? So we pull that formula up, and from here, we're just going to plug in the values that we have, right? So we're going to plug in 12 for B, 15 for C, do the same thing down here at 2BC, and then cosine of 42. And from here, it's just a matter of simplifying. 12 squared is 144. 15 squared is 225. 2 times 12 times 15 is 360. And cosine of 42. Still combining like terms here. We've got 369 minus 360. Cosine of 42. Now, there are some obstacles, some classic mistakes that you want to avoid. One of them is trying to subtract 369 minus 360. You can't do that. 360 has a cosine attached to it, so don't do that, okay? Instead, follow your order of operations. You would have to multiply these two together first and then subtract that result from 369. Or just use your calculator, right? Your graphing calculator or your scientific calculator, usually either one of those, will allow you to just type this in the way that you see it. So just type in 369 minus 360 times the cosine of 42 degrees. And if you type all that in and hit enter, you'll get 101.47, and the decimal goes on longer for that. Okay? The next classic mistake that you don't want to make is thinking that you're done right now, because you're not. That's a squared, and we want a. So to find a, just square root both sides. And if you square root your answer, you will get 10.07. Okay? And now I know usually when we square root to solve an equation, we have to include the plus or minus. We needed to make sure to do that in the last unit when we were solving those trig equations. And here we would do the same thing, only a stands for the length of the side of a triangle and therefore cannot be negative. So just using the positive side is perfectly fine. Okay? But that's it. That's all you got to do. All you have to do to use the law of cosines. And that's to find an angle measure, right? The next example helps us figure out what to do if we've got, if we want to find, sorry, that was to find the side length, the first one. The second one, we need to figure out how to use the law of cosines to help us find an angle measure. Okay? And so, we we draw our triangle, ABC, and then label the sides. Okay? Now, we are asked to find a specific angle. And this bubble suggests that you need to always find the biggest angle first. Now, here, we're not going to have to worry about it. We've been given side, side, side. We know that if we're given side, 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 there's only one way to make that triangle. So there's no issue in us finding whichever angle that we want. The reason why the suggestion is down here is to find the biggest angle first is because depending on how the information is presented to you and what we want to find, if you didn't find the biggest angle first, you might get yourself into a situation where you're in an ambiguous case like we had with law of sines. But that's not anything that we're going to have to worry about in this class. So I mentioned that. That's all I want to really talk about with it. At this point, we're just going to use the law of cosines and not worry so much about whether we fall into an ambiguous case or not. Okay? So we wouldn't here anyway because we've been given side, 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 and there's only one way to make that triangle. So if I want to go find angle A, I want to use the formula that has angle A in it, and that is your A squared formula again. And so we write that down, and then we go through and just plug in what we know. We know that A is 9, we know that B is 15, and that C is 21. Okay? 21. All right, and then simplify. So this is 81, 225, plus 441, minus, this is going to be 630, cosine of A. Now we have to work on getting cosine of A by itself, okay? So we're going to combine these like terms. We get 81 equals 666 minus 630 cosine of A. Okay? Now, classic mistake that you're not going to make, and I'm a little afraid to point it out, but we're not going to subtract 666 minus 630. We can't do that because 630 is attached to that cosine. Okay? So don't do it. Instead, we have to subtract 666 from both sides. And get negative 585. And then the next classic mistake is to not bring down that minus sign as a negative. So make sure that you do that. So you get negative 630 cosine of A. And then we're going to continue getting cosine of A by itself by dividing both sides by negative 630, not by adding 630 to both sides. And so we get 0.9286 equals cosine of A. And we look at that, and that decimal is definitely the weirdest angle we've ever seen, which tells us that it's not an angle, and so we have to remember to inverse cosine here. So if we inverse cosine that value, then the measure of angle A ends up being 21.8 degrees. Okay? And so there you go. That's how we use the law of cosines formula to find an angle measure. That simple. Okay? All right. Now you try it a couple of times. Here's one that has you go find the length of side A. So stop the video, give it a shot, you start it back up, and see how you do. All right. Right. In your notes, there is obviously a typo. A would have been 10. So you should have been looking for the missing side, which is B, right? We were looking for B here. Hopefully you realized that. But there's your work. Okay? Hopefully you got that. You needed to use the B squared formula this time because we were trying to find B. That's the only difference in the first one. Okay? If you didn't get that, make sure you come in and see me. We'll sit down and figure out why. Okay? Now, you try to use the law of cosines to find the missing angle measure. Again, stop the video, bring it back up when you're done, and see if you got it right. And there you go. We're going to use that cosine of C formula because that's the one that has angle C in it. Duh. And you should get 120 degrees. Okay? Even typing in the cosine of negative 0.5, that's going to get you your angle measure, 120 degrees. Don't get freaked out because it says that the value of cosine is negative. That's our way of getting an angle in quadrant 2. And it's still a valid angle to be in a triangle. Okay? All right. Now, the next problem in your notes is a situation where it just says solve the following triangles. Okay? So on a quiz, on a test, on a final, on a standardized test somewhere, if that's all you've been given and all you've been told, then just go in and label a triangle. So angle B is 73 degrees. Little a was 28. Little c is 46. Well, that's side angle side. And that means we need to use law of cosines. We can't use law of sines. Right? So the first thing I'm going to find is little b. Okay? I'm going to need little b to help us find angle A, angle C. So let's go use that little b formula. So b squared equals a squared plus c squared minus 2ac cosine of b. Little b we don't know, so we're going to plug in for a and c, which is 28 and 46. And then we're just going to, we know angle B, so we need to put that in there. I don't know why I didn't. So this is 73 degrees. All right, and just simplify. So 28 squared is 784. 46 squared is 2116 minus 2 times 28 times 46 is 2,576 cosine of 73. Okay. All right, so now we're going to add the 784 plus the 2116. That gets you 2,900 minus 2576 cosine of 73. Again, don't subtract the 2,900 and the 2576. We can't do that. You got to multiply the 2576 times cosine of 73 first. So when you do that, you do get 2,146.9, and then we're going to square root both sides. And so little b is 46.3. Okay? So now that we have little b, it might be tempting to switch over and try to use the law of sines with to find your missing angles, but you don't want to do that, right? Once we've started with law of cosines, continue with law of cosines. There are times where switching over to law of sines could create problems. I don't want to have to worry about that, so just once you start with law of cosines, stay with law of cosines. Now, pick the next angle you want to find. It doesn't matter which one, right? I'm going to go find angle A. So I need the angle A formula. A squared equals B squared plus C squared minus 2BC cosine of A. And plug in all of your values. So little a is 28. Little b is your 46.3. C is 46. Minus 2 times 46.3. Times 46, and then cosine of A. And now I'm just going to go through and simplify everything down. So 28 squared is 784. And then 46, that decimal, I'm going to bring the whole decimal down and square it. And then add to that 46 squared. And that's that result. Then we got to do 2 times that 46 decimal times 46, which is 426274 cosine of A. All right. Now we've got to subtract the 4262.85 from 784. I'm going to move that over here. So we get negative 3478.85 equals negative 4262.73. Make this a little smaller. Cosine of A. Now divide by the negative 4262.73. You get 0.8161. Then you have to inverse cosine to find the measure of angle A. Okay, so angle A is 35.3 degrees. And then what do you do to find angle C? Well, no problem. We're in a triangle, so just add that to 73 and subtract that from 180. and you'll find angle C. Which is 71.7 degrees. Okay? And that triangle is solved. So a little bit of work. 2 law of cosines to get you the missing side and one of the missing angles, and then just add those 2 angles up and subtract from 180, and that'll get you the other missing angle. Okay? All right. Then you try it. So here, again, we've been given the 3 side lengths, A, B, and C, little a, little b, little c, so label your triangle. And then, it says always find the biggest angle first. Don't worry about it. Since we have all 3 side lengths, you can find whatever angle you want. But all we need to do now is go find 2 angles. So law of cosines twice to find 2 angles, and then add them up, subtract from 180 to find the third. So go ahead and stop the video, work it out, start it back up, and see if you're right. Okay? All right, there you go. Your angles. Did you get 111.8 for angle C? 40.54 for angle B, and then 27.66 for angle A. Okay? Hopefully you did. If you did not, come in, sit down, we'll talk about it and figure it all out. Okay? All right. A couple of application problems for you, and then we're done. So during a hike, 2 hikers start, not stat, start at point A and head in the direction 30 degrees west of south to point B. Okay, so you have the picture there. They hike 6 miles from point A to point B, and then from point B they hike to point C, and then from point C back to point A, which is 8 miles directly north of C. How many total miles did they hike? So you have the picture drawn for you there. If not, we'd have to talk a little bit more about how to draw that, but we have it there. It says how many total miles did they hike? So they hiked from A to B and then B to C. I'm actually going to make that little a. B to C and then C to A. So to find out the total number of miles they hiked, we'd have to know all 3 sides and add them up. We're looking for parameter. Excuse me. So I just need to find little a. And we've been given side angle side. So that's my trigger to use the law of cosines. Since we're looking for little a, we need to use the a squared formula. And then just go plug in. Little b is 8 miles. Little c is 6 miles. I need to see this. I need to see you plugging in the numbers. And then from there, it's a matter of a bunch of button pushing. So if you didn't continue to show your work and rewrite steps, that would not be the end of the world. I will, just to show you the numbers and where they're coming from if you need to adjust them. But anyway. All right, 64 plus 36 is 100. Now we just type in 100 minus 96 times cosine of 30, and we get 16.9, at which point we're going to square root both sides. And so the length of A is 4.1 miles. Now, total miles, it's just going to be us adding 8 plus 6 plus 4.1, which is going to give us 18.1 miles. Okay? All right. Then you try. 2 airplanes leave Berlin, one heading straight for London, the other straight for Paris. The angle formed between the 2 planes is 18 degrees. Determine the distance from London to Paris. So stop the video, see if you can't find the distance from London to Paris. I'll show you what I got and make sure that you got it right. If not, come in and see me. But start the video back up and check your work. All right. As you can see, London and Paris are 290.4 miles away. Hopefully that's what you got. Okay. But if not, again, come in, sit down with me. We'll figure out why not. Otherwise, homework's out in Canvas. Go ahead and knock it out, and we'll go over it next class.